This is Precalculus Onramps Unit 2 review. This is the reviews that Precalculus Onramps puts together are the questions change, number one. Number two, this video is being made this year, 2025, after the review was already due. So this is just to be used by students for review purposes, to look at how each one of these questions was answered and then use that to get ready for a test. It's exactly the intended purpose. So I'm going to do all the questions here. And let me look at this. Number one, it says match each conic with its locus definition. So circle is a set of points equidistant from a locus. That's supposed to be a circle. So here's the locus, the center of a circle. And every point on the circle is r away from the circle. So they're equidistant. An ellipse, set of points. Now this one is such that an ellipse is like this. The locus for an ellipse is the focus. And if I take some point and I take the distances from the point, D1, D2, when I add them together, it always equals the same thing. So at any point, if I take the distance from one focus and the distance from the other focus and add them together, it will equal this D, which is, this is a set of points such that the sum of the distances from a point to the two locus, or both foci, or both, what is the plural of locus? Loci? I don't know. To the loci or to the locus, the sum of them is a constant. And then hyperbola is the same thing. I'll just draw one. Here are the foci of the hyperbola. If I take any point, then this is the difference. So this is the difference of the distances from any point to the loci. They're called foci, but this is asking about locus, loci. The difference is a constant. Parabola, let's just draw this one. Parabola has a directrix and a focus. And the distance from, I guess they're going to call it the locus, the difference from the focus to a point and the distance from the directrix, the line, and it's perpendicular, those two are equal. D1 equals D2. So those two are equal. That's that question. All right, number two, using the general form of a conic equation, ax squared plus cy squared plus dx plus cy plus f equals 0. Why is b missing? Well, b is a lot of times is just 0. It's bxy. That means, is it rotated? How do you tell if a circle is rotated? I don't know. You can't. But here's an ellipse, and if it's rotated, it could look something like that. And also a parabola can look rotated. A hyperbola could be rotated. An ellipse can be rotated. So that's the rotation term. That's the b. But a lot of times b is gone. It's just equal to 0. So using the general form, it's like the correct parameter. For a parabola, either a or c are 0. In other words, you won't see an x squared term or you won't see a y squared term. So either a or c are 0. For a circle, a is equal to c. They're exactly the same number. They're the same value, same sign. So a equals c. These are the answers, by the way. It showed the answer when I printed it, but I'm just going through them. For an ellipse, a does not equal c. They have the same sign, but they're different values. So it'd be like 3x squared plus 4y squared. Oh, look, it's an ellipse. Same sign, different values. And then for a hyperbola, a and c have different signs. So either the number in front of x squared is positive and the number in front of y squared is negative, or the number in front of x squared is negative and the number in front of y squared is positive. So that's that one. And oh wait, I accidentally zoomed out, or I don't know, made it small. But there it is. So that's question 2. Done. I'm not going to save it. Where's question 3? We're just going through this review. Question 3, which equation creates this graph? And I got a bunch of different equations. Well, number 1, an ellipse is always equal 1, and an ellipse is plus. So this is minus, that one's plus, this is minus, and these two don't equal 1. So none of those. So it can only be the first one and the second one. Now the question is, where's the center? Because this element is the same. The only thing difference are the sign on top. So let me see if I can get the center right. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that is the center. And that center is at 2 minus 3. Now remember, inside parentheses, the signs are going to be opposite. So it'll be x minus 2 squared, and then plus, and it'll be y plus 3 squared. This one has the wrong signs. That has x plus 2 and y minus 3. So there's the answer. That's question 3, just going through this review. I think there's 90 minutes for the review. If you really know this stuff well, you can probably complete this whole review in about 5 minutes. Question 4, x plus 1 squared minus 2 times y minus 2 creates which graph? Well, first of all, I see the x is squared, so it's either going to be at right side up or upside down. If the y was squared, it would be opening to the left or opening to the right. Now, since what's in front of this parenthesis is negative, it's going to be an upside down one. So that's what it's going to look like. So let's see. This one's out. That's right side up. This one's out. This one's out. Uh-oh. This one's out. This is the only possibility. So remember, the equation is x minus h squared equals 4p times y minus k. And then for the vertical one, it's y minus k squared equals 4p x minus h. And if the 4p is positive, this one's going to be like this. If the 4p is negative, if the 4p is positive, if the 4p is negative on that one. So there's only one possibility. I can check to make sure the vertex is right. It's the opposite sign, so it's negative 1, 2, negative 1, 1, 2. Okay, but it's the only one that's a vertical parabola that goes down. So just from that, I got the answer. All right, next one. This is question 5. There's 20 questions. Oh, why are they asking 20 questions? Okay, this is y minus 1 squared over 16 minus x plus 2 squared over 9 equals 1. Again, if this is a hyperbola, if the x squared term is positive, it's going to be a horizontal hyperbola. If the y squared term is positive, it's going to be a vertical hyperbola. Well, this one, y squared, is positive, so it can't be that. That's a horizontal. Can't be that. That's a horizontal. It could be either one of those two. So now the question is, where's the center? Again, opposite signs, so it's negative 2. See, that's where the x is. And plus 1. So negative 2, 1 should be the center. Let me check. Negative 2, 1. 1, 2, 3, 4. 1, 2, 3, 4. So that is, in fact, the center. Let me try this one. Negative 2, 1. 1, 2, 3, 1, 2, 3. Okay, the center is right in both cases. So now I've got under the y is 16, which is 4 squared. That means the distance up and down between the center and where the lines are should be 4. 4 squared is 16. So let me check. 1, 2, 3, 4. That one is 1, 2, 3. That one isn't. The answer is that one. They don't even give A, B, C, D. You just have to select it. All right, that's question 5. Let me try question 6. Convert the general form to standard form. Remember, first of all, what is this? The signs are the same. The numbers are different. This is an ellipse. So I'm going to put the x's together. 9x squared minus 72x plus 4y squared plus 48y, and I think I'm going to need a little bit more room, equals, I'm going to subtract 144 from both sides. Okay, then I'm going to divide this by 9. 9 times x squared, 9 times negative 8 is negative 72, minus 8x, I'm going to leave a space. And this is plus 4, and that's going to be y squared. 4 times 12 is 48. It's supposed to be a y. I'll leave a space. I need even more room. Equals negative 144. So now I bring this y down, I bring this 4 down. Now, half of negative 8 is negative 4. So I'm going to put in parentheses x minus 4. And that's going to be squared. Negative 4 squared is 16. And then 9 times 16, 54, that's 144. It goes over there. Whatever I add to this side, 9 times 16, I have to add to that side. Same thing with this. Half of 12 is 6. So this is going to be 4y plus 6 plus 6 squared. 6 squared is 36. And then on this side, I have to add 4 plus 36, or 4 times 36, which is another 144. Negative 144 plus 144 is 0. And then there's 144 still there, so that's 144. Now all I have to do is get this equal to 1. So I will divide everything by 144. Divide it by 144. Divide it by 144. And I've got equals 1. And then 9 divided by 9 is 1. 144 divided by 9 is, let me put the x minus 4 squared part here. 144 divided by 9 is, 9 times 1 is 9. 54, 9 times 6. So that's 16 plus 144 divided by 4. I'm going to put the y plus 6 squared. 144 divided by 4. 4 times 3 is 12, 24, 36. So it's 16 and 36. So I have h, it's x minus 4. Y plus 6 is y minus negative 6. So that's why I put negative 6 in there. Y minus negative 6. Let me get rid of that mark so it doesn't confuse people. Y minus negative 6 is y plus 6. D is 16. That's the number one under the x minus 4 squared, and E is 36. So that's question 6. We'll get there. We're going to get to 20. Believe me, we'll get there. The following problem solution has a mistake. On what row does the mistake occur? What is the correct standard form? You do not need to show work. Okay, so let's see. I collected the x's, 5x squared and 30x. Collected the y's, negative 12y squared plus 144y, and I put this negative 447 on the other side. So that row is right. Then I factored out 5. 5 times x squared plus 5 times 6 is 30. That's good. Negative 12. 144 divided by negative 12 is negative 12. That is right. Next one, I completed the square, so half of 6 is 3. 3 squared is 9. Half of negative 12 is negative 6. Negative 6 squared is 36. Then on this side, I'd have to add 5 times 9. Oops! That should be 45. And I have to add negative 12 times 36. I'm just multiplying by hand. This is 2, 13, 432. And that's a negative. Negative 12 times 36, so I have to subtract 432. So there's the mistake. I did not multiply by those factors, and so I added the wrong things. So on the right-hand side, it should be 447 plus 45 minus 432, which is 7 and 5 is 12. 4 and 4 is 8, 9. So 492 minus 432 is 60. So it should be, well, it's 447 plus 45 minus 432. That's literally what that line should be, and that should be equal to 60. And this should be, now, each one of these rows now contains the same mistake, but this row 3 is where the mistake was made. So hopefully that's all that's wanted. So that should be 60, and that should be 60. Because the question asks, on what row does the mistake occur? So the mistake keeps going, but the mistake occurred on row 3. And this should be 60 over 5 is 12, and this should be 60 over 12 is 5. So the mistake occurs on row 3. I should have added 445 and subtracted 432, and then the final answer is going to be x plus 3 squared over 12 minus y minus 6 squared over 5 equals 1. That's the correct standard form, and that's what it asks for. On what row does it occur originally? That's row 3. What is the correct standard form? There it is. Don't have to do the work. And so this is what the student wrote. Mistake in row 3 did not multiply factors. And so that's correct, and then standard form. I think when this student filled it out, put x minus 3 squared originally instead of x plus 3 squared. So it would have marked it wrong, but just make sure you keep your signs straight. Okay, next one. Question 8, determine the location of the focus and the directrix. Well, this is the same thing. I put, I've got to get this into this form. X minus h squared equals 4p y minus k. So I'm going to have to do some completing the square. X squared plus 8x. I'm going to get the y's on the other side. Equals, I'm adding 8y to both sides. I'm adding 8 to both sides. Now, what is half of 8? Half of 8 is 4. So it's going to be x plus 4 squared. 4 squared is 16. If I add 16 to one side, I've got to add it to the other side. So this is equal to 8y plus 24. I want the y to be by itself, so I'm going to factor. I factor out the 8. 8y divided by 8 is y. 24 divided by y is 6. And this is x plus 4 squared. So what's it asking for? The focus and directrix. Well, first of all, I see that the x term is squared, and this is positive, so this parabola looks like this. If the x term is squared and that is negative, it'll look like this. If the y term is squared and that were positive, it would look like this. And if the y term is squared and the number in front of x minus h, whatever, was negative, it would look like that. So I know that there's going to be a vertex, and then the focus will be above it, and the directrix will be below it. So let's find the vertex. Remember, it's x minus h, y minus k. Just switch those signs. Negative 4, negative 6. And now, if 4p equals 8, p equals 2. So it's going to be p. The focus is going to be p above this. And what have I done? I think I did something wrong here. I'm thinking, because I remember the answer. Plus 16 is 24. Oh, 8 doesn't go 24 6 times. It goes in 3 times. All right, so why didn't you correct me? So this is negative 4, negative 3 is the vertex. I knew something was wrong there. P equals 2, so it's going to be, the focus is going to be 2 above, which is negative 4, negative 1. That's the focus. And then the directrix is going to be 2 below, but it's a line. So 2 below negative 3 is y equals negative 5. That was question 8. Next. Question 9 says, use the function x squared minus 6x plus 13 to answer the following. Algebraically find the vertex and y-intercept. Well, I can say that's equal to y, and the y-intercept is when x is 0. So the y-intercept is 0 squared minus 6 times 0 plus, that's a 13, equals 13. So there's the y-intercept. Y-intercept is when I said x equals 0. Now, to get the vertex, I'm going to put this into x minus h squared equals 4p y minus k. And I will do that by completing the square. I set that equal to y, so this is x squared minus 6x. I'm going to leave a space equals y minus 13. Now, half of negative 6 is negative 3. So this is x minus 3 squared. Negative 3 squared is 9. And if I have 9 there, I have to put 9 there. So this equals y minus 13 plus 9 is y minus 4. And so the vertex is at 3, 4, just the opposite signs. X minus h, so minus 3, y minus k, so it's y minus 4. So the vertex is at 3, 4. So there's the vertex, and there's the y-intercept. That's question 9. Almost halfway done with this review. Hooray! Okay, this next one is, wait a minute. Question 12. Oh, wait, there's more questions on this page. I forgot about this. So that was question 9. Here's question 10. Which of the following are the roots of 2x squared plus 8x plus 9? And to get the roots, I set it equal to 0. And remember, the roots are where a parabola crosses the x-axis. Sometimes it doesn't. It doesn't cross the x-axis. There are no real roots. They're imaginary. See these little eyes in here? Those are imaginary. So this is no calculator. You can't graph this thing. So you have to, well, I guess you could graph it and kind of figure out the shape of it and see if there are real roots, and you'd figure out if there's imaginary roots or not. But I'm going to do it a different way, which is set it equal to 0 and use the quadratic equation. Remember, this is ax, or quadratic formula, squared plus bx plus c. So a is 2, b is 8, c is 9. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative b is negative 8, plus or minus 8 squared is 64, minus 4, a is 2, what was c again? c is 9, all over 2 times 2, which is 4. Oh man, let me get more room. I've always got to make more room. Okay, so this is negative 8 plus or minus the square root. 4 times 9 is 36, times 2 is 72. 64 minus 72 is negative 8, all over 4. Now, if this is negative, it doesn't have real roots. It's imaginary. So at least I can get rid of that answer, and it's going to be one of these three. I think they all, yeah, with the I in it. So I have to put an I outside of the square root to get the, take care of the negative. I square root of 8 over 4. Well, can I simplify square root of 8? 8 is 2 times 4. I found a perfect square factor, so I'll take the square root of that. So this is negative 8 plus or minus square root of 4 is 2, and what's left inside, and that I is there, what's left inside is 2 over 4. And now I can separate this. Negative 8 over 4 is negative 2. 2 over 4 is 1/2. I'll just put 2 under there. 1 is understood. And this is I square root of 2. So negative 2 plus or minus I square root of 2 over 2. Let me zoom in. And that is this one. Very good. The next one, question 11, it wants to multiply matrix B times matrix A. Remember, to multiply it, I have to check the rows and columns. This is a 2 by 3, and A is a 3 by 3. And to multiply them, the middle numbers must be the same, and the result will be the outside number. So the result of this is going to be a 2 by 3 matrix. And so this says B times A, so it's going to be 9, negative 5, negative 2, 0, 3, 8, times A. 1, 3, negative 2, 0, 6, negative 1, negative 4, 1, 7. Normally, you'd throw this into a calculator, but this sinister review and obviously the test wants this done by hand, so I have to do this by hand. I'm going to go across times down and add each term, or add each one. 9 times 1 is 9, minus 5 times 0 is 0, negative 2 times negative 4 is 8, so that spot's going to be 17. Now I do the next one. Across times down. 9 times 3, 27. Negative 5 times 6, negative 30. Wait, is that negative 2? Yeah, that should be negative 2. I don't know why that got so big, but I was worried that I didn't know what this was supposed to be. I'm going to rewrite that one just so I don't get confused. Negative 2. So I did 9 times 3 is 27. Negative 5 times 6 is negative 30. Negative 2 times 1 is negative 2. And let's see what that is. Negative 32, 27. That's negative 5. I'm going to do the first row times the third column. 9 times negative 2 is negative 18. Negative 5 times negative 1 is 5. And negative 2 times 7 is negative 14. That's negative 32 plus 5 is 27. Then I'm going to do the second row. 0 times 1 is 0, plus 3 times 0 is 0, plus 8 times negative 4 is negative 32. So in that spot I've got negative 32. Then I'm going to do 0 times 3 is 0, 3 times 6 is 18, and 8 times 1 is 8. 18 plus 8 is 26. And then for the last spot in the second row, 0 times negative 2 is 0, 3 times negative 1 is negative 3, 8 times 7 is 56. 56 minus 3 is 53. So there is the result of that multiplication: 17, negative 5, 27, negative 32, 26, 53. And I think originally, when I worked this, I got positive 5. I forgot the negative sign. So always double check your work on these. But anyway, that's how to do matrix multiplication. That's question 11. We're more than halfway done with this test. And now I've got to find question 12. Question 12. Question 12 says C minus A. Well, this is easy. I just take whatever's in C and subtract whatever's in A, and the matrices have to have the same dimensions. If it was like, if it was A times a matrix, let's say this was 1, 2, 3, 4, 5, 6, 7, 8, 9. When you're multiplying, that's called a scalar by just a number. You just multiply it by each position. So this would be 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, 9A. But this is subtraction. So negative 3 minus 1 is negative 4. Negative 2 minus 3 is negative 5. 4 minus negative 2 is 4 plus 2 is 6. 7 minus 0 is 7. 5 minus 6 is negative 1. 1 minus negative 1 is 1 plus 1 is 2. 8 minus negative 4 is 8 plus 4 is 12. 0 minus 1 is negative 1. 9 minus 7 is 2. So that would be the result of that subtraction. That was question, I don't know what question, question 12. I just want to make sure, so I do all of these. Okay, here's question 13. Question 13, find the inverse of the following matrix. Now, to find the inverse, I'd plug this into a calculator. It's not going to make you do the whole thing. It gives you part of it, and it's just going to ask one question. So it says, switch row 1 and row 2. So notice row 1, this is row 1, row 2, row 3. All I did is put row 2 on top and row 1 in the middle. I just switched them. That's exactly what it said. Now, how is this next operation done? How do I get from step 1 to step 2? Notice the top row is the same. Row 3 is the same. So something has been done to row 2. And let me see. This is 3 and it becomes 0. So I can add 3 times row 3. 3, so I can do it. Let's see if this works. Row 2 equals row 2 plus 3 times row 3. Because 3 plus 3 times negative 1 is 0. I'm trying to get 0, 6, negative 24. Negative 3 plus 3 times 3 is 6. And then negative 24, which is, I'm doing row 2 plus 3, row 3, 6 plus 3 times negative 5 is negative 15, and negative 15 plus 6 is negative 9, and I need negative 24. That didn't work. So let's try something else. Row 2 equals row 2 minus 3 row 1, because 3 minus 3 times 1 is 0. So let me try that one. 3 minus 3 times 1 is 0. 6 minus 3 times... wait a minute. Negative 3 times negative 3 times negative 3 is 9, and negative 3 plus 9 is 6. And then this last one, 6 plus negative 3 times 10 is negative 30. 6 plus negative 30 is negative 24. So this is what is actually done. Row 2 equals row 2 minus 3 row 1. That's the answer I put. It marked it wrong. So I'm thinking this had to be an equals. When we put an arrow pointing, it didn't like that. That's how I usually write it, but it probably had to be an equal. Sometimes with these computer tests, it's a chore to figure out how it wants it entered. But anyway, that's question 13. Here's question 14. Hopefully I've got that on a separate sheet, or I might be in trouble here. No, I copied it. All right. The goal is to get the left side to be the identity matrix, which yields the inverse on the right. About halfway through the process of finding reduced row echelon form, the matrix is achieved, blah, blah, blah. Start with the augmented matrix above. Augmented means I've just put the identity matrix on the right side, and do these following mathematical instructions. So I'm starting with this, and row 2 is row 2 minus row 1. So I do row 2, row 1 stays the same. And row 2 is equal to, I'm just following this instruction, row 2 minus row 1. So 1 minus 1 is 0, 0 minus negative 1 is 1, negative 1 minus 0 is negative 1. I'm doing row 2 minus row 1. 0 minus 1 is negative 1, 1 minus 0 is 1, 0 minus 0 is 0. Now I've got two instructions. I've already done that one. I've got two for row 3. So instead of rewriting it over and over, I'll do the first one for row 3 and then do the second one and then get the resulting row 3. So row 3 equals row 3 minus 6 row 1. 6 minus 6 times 1 is 6 minus 6 is 0. Negative 2 minus 6 times negative 1 is negative 2 plus 6, which is 4. Negative 3 times negative 6 times 0, negative 3 minus 6 times 0 is still negative 3. That just stays the same. 0, I'm just doing row 3 minus 6 row 1. 0 minus 6 times 1 is 0 minus 6. 0 minus 6 times 0 is 0. 1 minus 6 times 0 is 1. So row 1 and row 2 are still going to remain the same, so I'll just do my operation on row 3 now. I'm going to do row 3 minus 4, row 2. 0 minus 4 times 0 is 0. 4 minus 4 times 1 is 4 minus 4 is 0. Negative 3 minus 4 times negative 1 is negative 3 plus 4 is 1. And then negative 6 minus 4 times negative 1. Minus 4 times negative 1 is 4. Negative 6 plus 4 is negative 2. 0 minus 4 times 1 is negative 4. 1 minus 4 times 0 is still 1. So this is my row 3. It's going to look like that. So so then I just have to enter A is negative 1, B is over here is 0, C is negative 1, D is, you can see where the D is up here, is 0, E is 0, and then F and G, F is negative 2, yes, and G is negative 4. And I think when this was worked, ran out of time doing this one. The student ran out of time. So anyway, I just finished it. But that is question number 14. So who knows? Maybe on the test, it's not going to ask you to find the inverse completely by hand. It'll just ask you for certain steps. Okay, this says a calculator is allowed. A circle passes through 3, negative 1, negative 2, 4, and 6, 8. Use a general form of a circle and the points above fill in the missing numbers to create a system of equations. I guess I have room to do this up here. So I'm going to do 3, negative 1, negative 2, 4, and 6, 8. So I did x squared. Remember, it's x, y. So x squared is 3 squared is 9, plus negative 1 squared is 1, plus dx, so plus 3d, plus ey, so y is negative 1, minus 1e, and then it's just plus f, equals 0, but this 9 plus 1, I don't want it there. I want it on the other side. So 9 plus 1 is 10. I subtract 10 from both sides, negative 10. So the first one is 3d minus 1e, and then negative 10. And now the next one, I've got negative 2, 4. So I've got x squared, negative 2 squared is 4. Y squared, 4 squared is 16. So that's 20, but I want it on the other side, so I'm going to put negative 20. And then I've got dx, so negative 2d, plus ey, so plus 4e, plus f, equals negative 20. So this one is going to be negative 2, e is 4, f is just 1, and this is negative 20. And now the last one, x squared. 6 squared is 36, plus 64, that's 100, but I'm going to put it on the other side, negative 100. And then I've got 6d plus 8e plus f equals negative 10. So negative 100, not negative 10. 6, 8, 1f, negative 100. So that would be it. Let's see. Remember, in order to then solve this, after I have this in the equation, so 3, negative 1, this is 1. Negative 2, 4, 1. 6, 8, 1. I would find the inverse of that and then multiply it by this matrix, and that would give the answer. I think I'm going to copy this because the next question may be a follow-up on this if I remember correctly. So I'm just going to copy that, and then I'm looking for question 16. Is this question 16? Yeah, this is 16, even though I deleted the number, but it says, solve the system of equations that you created and write the equation for the circle by filling in the values of D, E, and F. And it said this is 15 part 2, I guess. Wait a minute. Is this 15 part 2? Because this is question 16. Yeah, that's 15 part 2, and I can use the calculator. So all I have to do is put those numbers into a calculator, and I'll do it I'll try it in Desmos, and I think I already did it. 3, negative 1, negative 1. Wait a minute. Boy, when I did it before, I did it wrong. It's 3, negative 1, 1. And then negative 2, 4, 1. And then 6, 8, 1. And then the B matrix is negative 10, negative 20, negative 100. And you can see I did A, the inverse of matrix A, times matrix B. And I get negative 6, negative 8, and 0. 3, negative 1, 1. Oh, man, I had that one backwards. Negative 2, 4, 1. And 6, 8, 1, I've got that right, negative 10, negative 20, negative 100. So the answer is negative 6, negative 8, 0. So what is this? DEF, I think? DEF. So D, whoops, I don't have my pencil. D is negative 6, F is negative 8. E is negative 8, and F is 0. 3, negative 1, 1. Yeah, I originally had this 1 up here in the top right. I had it backwards. Negative 2, 4, 1, and 6, 8, 1. I'm just double checking. And negative 10, negative 20, negative 100. All right, so that's that one. That's 15 part 2. And you're able to use a calculator. So I'll make sure to put a link to how to solve a matrix in a TI-84. I use Desmos. All right, this is 16, and this is pretty similar. A vertical parabola goes to 1, negative 2, negative 3, 10, and 4, 31. Use the matrices to solve for D, E, and F, given the general form. Since this is a vertical parabola, there's not a y squared term. So let me do the points. Here's 1, negative 2. Since it is a vertical parabola, yeah, so a vertical parabola is either like that or like that, and y isn't squared. So 1, negative 2, negative 3, 10. And you got to be careful here because you've got to make sure if there's no B term, or rather no D term, no E term, no F term, you got to put 0 for those in the matrix. So 1 minus 2. So it says there is no y squared term. Gone. So this is x squared. 1 squared is 1 plus dx, which is 1d, plus ey, so minus 2y, plus f equals 0, except I'm going to subtract that 1 from both sides. So d minus 2y, not 2y, that should be 2e. Why don't you correct me when I make these mistakes? Because remember, I'm putting in 2 for y is negative 2, negative 2e, so that should be negative 2e. So I have 1, negative 2, 1, negative 1. It says use matrices to solve for D, E, and F, but the answer choices are only to fill in the matrix, so I don't think it actually has to be solved. All right, now I'll do the second point, negative 3, 10. Negative 3 squared is positive 9. I'll subtract 9 from both sides, and then I get dx, so negative 3d, plus ey, so plus 10e, plus f, so this is going to be negative 3, 10, 1, negative 9. And then the last one, 4 and 31, x squared is 16. I'll put minus 16. And then it's going to be dx, so 4d, ey, 31e, plus f, and that's the last row, 4, 31, 1, and negative 16. And then that's it. That's it for this question. It doesn't actually ask for the solution, because they don't want you to have to solve it by hand. You could use a calculator very easily. Question 17. An ellipse or hyperbola of the general form ax squared plus ci squared plus dx plus ey plus f equals 0. Solving for 5 unknowns requires 5 equations and 5 points. However, if one of the coefficients is divided out, a or c, then only 4 coefficients remain and only 4 points are needed. Given a 4 points on a vertical ellipse, fill in the matrix. All right, so this just wants the matrix again. So I will figure this one out. Let me give myself some more room, and I will go like this. I'm zooming in so I can see it. Your eyes might be better than mine so you can see it. So notice I have taken the a out. It would be something like, just an example, what if I had 3x squared plus 6y squared plus 9x plus 12y, and this is supposed to be an ellipse, did it say? Oh, ellipse or hyperbola, so I'm okay. Plus 9 equals 0. So I could divide everything by 3, and this would be 6 divided by 3 is 2, 9 divided by 3 is 3, 12 divided by 3 is 4, 9 divided by 3 is 3. So I got rid of the a term. I just turned it into 1. So here's my points. I'm going to make some room down here. And again, remember, see these zeros in here? I'm going to have some zero. I'm going to have like 0e or 0d or something, but I still have to put zeros in for those in the matrix, or else it's not going to solve correctly. So I've got 3, 0, 0, 2. Those are placeholders. 1, minus 7, and negative 1, negative 5. So I have x squared, which is 9, plus cy squared, which is 0, so there's no c. So I'll just put 0c. dx, which is plus 3d. I just want to make sure that I don't forget to put that 0 in the matrix. Plus ey plus 0e plus f equals, and I will subtract 9 from both sides, negative 9. So in this spot in the matrix, I'm going to put 0, 3, 0, 1, and then negative 9. This one is 0 squared is 0. So if I subtract 0 from both sides, it's still 0. cy squared, y squared is 4, so 4c, plus 0d, because it's d times x, plus y times e, or e times y, 2e, plus f equals 0. So this is 4, 0, 2, 1, 0. That's what I'm putting in the matrix. Next one, 1 squared is 1. I'm going to subtract 1 from both sides. cy squared, negative 7 squared is 49, so it's 49c. Plus dx, so plus d, x is just 1, plus ey, so minus 7e. E times y is minus 7e, plus f equals minus 1. So in the matrix, I'm going to put 49, 1, negative 7, 1, and then minus 1 in the solutions matrix, which is going to be a 4 by 1. And then the last one, negative 1 squared is 1. I'm going to subtract that 1 from both sides. And then I'm going to do cy squared. So negative 5 squared is 25. C. X times d is negative d, negative 1d. E times y is negative 5e plus f. So that's what I'm going to enter into matrix. It's going to be 0, 3, 0, 1, negative 9. 4, 0, 2, 1, 0. 49, 1, negative 7, 1, negative 1. 25, negative 1, negative 5, 1, negative 1. That's what the matrix is going to look like when I fill it out. But I don't have to actually solve it. Next one. So here's question 18. And I know this is a reflection over the x-axis. So I put a minus outside of what's happening to x. The vertex, which is usually at 0, 0, is at 2, 3. So this is going to be x minus 2 plus 3. Now I've got to figure out what this stretch is. And I know there's a stretch or compression of some type because it's not going right through the vertices. It's not going through the corners of the squares. See how it's not going through here. It's not like this. So it's stretched. Okay, so let me figure this out. I will take a point, which is 5, 1. So when y equals 1, x is 5, negative a. 5 minus 2 is 3. Absolute value of 3 is 3. Plus 3. And I have subtract 3 from both sides. Minus 2 equals negative a times 3. I'll divide both sides by, well, I can also write that as negative 3a. I'll divide both sides by negative 3. And I get 2/3 equals a. And I will check it in a moment. I get y equals negative 2/3. Now, a is 2/3, but that negative sign is there. So it's negative times 2/3, which is negative 2/3. X minus 2 plus 3. Now I'm going to test one other point, which is I'm going to check this point to make sure it works. Negative 1, 1. So when I put in negative 1 for x, I should end up with 1 as the y value. And let me do this. Negative 1, 1. Y equals minus 2/3. Negative 1 minus 2 is negative 3. Absolute value of negative 3 is 3 plus 3. Negative 2/3 times 3, well, the 3's cancel, and that's negative 2. Y equals negative 2 plus 3 equals 1. So when x is negative 1, y is 1, I verified that I've got the right equation, which is this. Y equals negative 2/3, absolute value x minus 2 plus 3, and then you'd have to fill this in, however it's filled in. Okay, that was question 18. Let me go to 19. Where is 19? 19. Fill in the blanks below with the correct values that result from these transformations, reflecting the value on the x-axis, and it's a cubic function. So it's cubic, and I'm going to put a negative there. Now, to be careful, I usually put negative x cubed like that. So I know that I'm not, the negative part isn't also being cubed. I guess it doesn't matter because it only matters with squared. So you can just write it like that. If it's squared, you know, negative number squared is positive, so make sure the negative is outside of parentheses, but whatever. Reflecting the function x-axis, that puts a negative there. Vertical stretch by a scale factor of 3. Boop. 3x squared. The 3 is not being squared. Right, it's a vertical stretch. Shifting left 4 units, well, negative 3, and it's going to be x. Left is positive. If I shift that way, it's positive. If I shift that way, it's going to be a negative. If I shift up, it's positive. Shift down is negative. Because it's x minus, and that's why it flips everything. So it's a shift left units 4, so this is going to be plus 4. And then that whole thing is cubed. That's what happens. The horizontal shift, left and right, goes in with x. So x is being cubed. The 4 has to be cubed. and then shifting up 5 units. So this is plus 5. So this is going to be, when you enter this one, it's negative p equals 3, x minus q. Now be careful here, x minus cube, it's plus 4, so it's x minus negative 4. And then r is equal to 3, and then t is equal to 5. So that's number 19, and now the last one is number 20. Given this graph, create the function that makes this graph by selecting the correct pull downs. Well, this is a square root graph. Y equals square root x looks something like this. So I can see this is reflected over the x-axis, but if it was reflected over the x-axis, it looked like this. It's also reflected over the y-axis. So I have to have a negative in front of the square root and a negative in front of the stuff that's happening to x. And then let me see, usually it's at 0, 0. This looks like it's at 3, negative 4. So remember, it's 3 to the right, so that's negative 3, x minus 3. And then it's negative 4, so I almost put positive, negative 4. And I'm looking at this, it looks like inside the square root there's a number, and then this is in parentheses. So that's fine. If it didn't show that number in parentheses, I'd have to multiply through it. It'd be negative x plus 3. But because it kept it in the parentheses, the negative goes in front of it. So that's what you would enter, and however it's entered. It would be negative, and then this would be negative, and then x minus 3, and then minus 4. So I don't have all the selections there, but this is what you'd have to enter. And with that, this pre-calculus on-ramps review is finished.